So let's talk about rule-based access control, RuBAC, not to be confused with role-based access control, or RBAC. And as you might imagine, rule-based access controls allow you to set access based on rules. So RBAC, rule-based access control. According to NIST 7316, it's allowing access based on pre-configured rules. There's really no formally defined standard or definition for what these rules have to be or what they have to look like, but you can also combine these to make it even more complex. You combine these with role-based access control, discretionary access control, mandatory access control, with other more formal models of access control. So how you would actually combine those rules? Well, if you're going to combine RBAC with RBAC, let's see if we can keep all these acronyms straight. If we combine it with role-based access control, what we're really doing is using my role as a subject as an attribute in a rule. So if I'm a manager, we can use the fact that I'm a manager, what my role is, as part of a rule. Like only managers are allowed to access the facility after 5 p.m. Policy-based access control, so now I can implement policies based on rules which define what that policy is and what we're allowed and not allowed to do. I can combine it with discretionary access control where now users are allowed to control or configure the rules that they're privy to. And then mandatory access control, we can combine it and say that rules can't be changed. They're controlled by security labels instead. Here's a good example of rule-based access control. This is a firewall access list. And as common with rule-based approaches, you'll see that they typically take the form of some keyword, like an IP address, and some type of action, like allow or deny or redirect. As you probably have seen in firewall implementations, it's common to have either allow by default or deny by default. Allow by default means you're taking a blacklisting approach to access control and saying only these certain sites you can't go to. Everything else, you can. The more secure way of doing things is through whitelisting, which requires a deny by default. So you can see here in this example, if we go through each of these rules and I don't match this one, I'm not matching this one, or the 10.2 rule down here, my default is I'm not allowed to do it. If we didn't have this rule down here, then I would be allowed to do it because there wasn't anything that specifically allowed me to not do it, for lack of a better word. The best way to show this is through as an example. And we'll take the Department of Motor Vehicle Services sign here as a good example. So the DMV says, if you want to come in here, you can't bring food, you can't bring any type of drink in here, and don't be cussing while you're in the DMV. If you meet all that, and we're open, because we're open from 9 to 5, Monday through Friday, then yes, you can come in. Any other time, you're not allowed to do that. So here are the rules for this. If you have food, you're denied. If you have a beverage, you're denied. If you start swearing up a storm, you're denied. But we're open from 9 to 5, and if you haven't been caught by any of these previous rules, come on in. If it's not 9 to 5, meaning this rule doesn't apply, then we deny, and we say, sorry, you can't come in. What would happen if we didn't have this deny statement down here at the bottom? Well, as long as you don't have any food, and you don't have any beverages, and you're not swearing, you'd be allowed to come on in because the default would be allow. And what that would cause is that people are trying to get into the DMV at 3 o'clock in the morning. That's a good example of how a rule-based access control, it's important to have a deny by default. That way you don't have unexpected results. An access control matrix is a good way to visualize the rules in a rule-based access control system, but they're really terrible for actually implementing these rules. So you can do it, and in this case you have subjects here in the column on the left, You have objects, the things that they're allowed to do stuff to, and in the middle, in the matrix itself, you have the permission levels. So for subject 1, person 1, for object 1, whatever that object might be, I'm allowed to read and write it. These get very ungainly when you have multiple subjects and multiple objects. So generally speaking, these are great for visualizing rule-based access control approaches, but terrible for the actual implementation of it. The more sophisticated a rule-based approach gets, the more complicated rules it can enforce. And this can be very powerful because you can set very granular rules on what is and is not allowed to happen. So for example here, we say that user X can only access file Y between 7 a.m. and 6 p.m. Okay? User X can only get into the room if user Z allows them in. Or perhaps if they're already in, then user X can get in. User X can only open room 1 if the fire alarm is on. You can see from a security perspective how powerful these rules can be. The downside to this, of course, is that you have to specify each case, and it can get very ungainly. But from a security perspective, you have fine-grained control over what you can allow and what you don't want to allow. This becomes very powerful from a intrusion detection or intrusion prevention perspective, where this is going way beyond just simple firewall ACL rules. Now you can allow a system to take an action based on something that's known to be bad or certain conditions, whatever meets your rules that you've set. You're now allowing the system to take action on that. So you can trigger based on things like if I see a string called, or if I'm looking at files and I see the string etsy/shadow go across in that file or in a packet, I can take some type of action. If I see that a computer belonging to a developer is trying to access something outside his area, perhaps in payroll or HR, I can block that access or I can deny that. If I see packets containing a file that calculates to an MD5 that I recognize as a known bad, I can take action on that. If a packet contains a known compromised credential, like a revoked certificate or something like that, I can take action on that as well. So from a security perspective, the rule-based approach makes a lot of logical sense because you can check for specific cases or specific instances of bad stuff happening. The downside, of course, is that you have to know what that bad stuff is in order to define the rules.